Hello students, today I am going to conduct one very interesting and important activity. I have taken a glass tumbler which is filled with water and one pencil. You see, the pencil, when it is viewed, it is straight. Now, when it is immersed inside water, let us see what will happen. See now, it is clearly visible that it appears to be bent, which was straight outside water. Why this is happening? What is the reason behind it? To know the reason, we have to go for a concept that is called refraction of light. Dear students, what you have seen from the activity, that when a pencil placed inside water, it appears to be bent. Similar phenomena are also observed in your day-to-day life. If you place a coin, suppose under water, it appears to be raised. That means its actual depth and apparent depth, they are different. This is also due to a phenomenon of light called refraction of light. You might have observed the sun appears bigger in the time of sunset or sunrise than in the noon time. And also, sun is visible 2 minutes before sunrise and 2 minutes after sunset. Many phenomena are there based on the refraction of light. Then what is refraction of light? The refraction of light means it is the change in the direction of path of light when it travels from one transparent medium to another. That means when light is traveling from one medium to another, then its direction changes. This phenomenon is called refraction of light. Why it changes the direction? It changes the direction because the speed of light is different in different media. You say the speed of light in air or vacuum. It is represented by symbol c. C is equal to 3 into 10 to the power 8 meter per second. This is the speed of light in air or vacuum. If you say speed of light in glass, that will be approximately 2.0 into 10 to the power 8 meter per second. Similarly, if you say speed of light in water, VW, so that will be 2.25 into 10 to the power 8 meter per second. The speed of light is different in different media. That's why when light travels from one medium to another, it has to change the direction. And it is not always. When light incident obliquely, you will observe when light falls normally, for normal incidence, there is no refraction, no change in the direction of path of light when it incident normally on an interface separating two media. So, the change in the direction of path of light when it travels obliquely from one transparent medium to another is known as refraction of light. Then what is the cause? The cause of refraction is the speed of light is different in different media. So this is the cause of refraction. Then how the refraction takes place when it is traveling from one medium to another, let us see. We can define a term here called optical density. All of you know what is mass density. It is the mass per unit volume, that is mass density. but mass density and optical density, so they are different. Mass density, the mass per unit volume, whereas optical density depends upon the speed of light in a medium. If you compare two medium like water and glass, one medium is called rarer medium, other medium is called denser medium. You know the speed of light in glass is this much, speed of light in water is this much. The medium in which speed of light is more, that is called a rarer medium in comparison to the other one. So if you compare here glass and water, speed of light is more in water in comparison to glass. So here glass is the denser medium and water is the rarer medium. Now I will show when light travels from a denser medium to rarer medium, in which direction it bends or it changes the direction. How? Now I have drawn one interface that separates two media. Suppose this is medium 1, this is another medium 2. Now suppose it is going from, the upper one is a rarer medium, lower one is a denser medium. And when light travels from a rarer medium to a denser medium, it bends towards the normal. This is the normal, it bends towards the normal. This is your angle of incidence, this is the angle of refraction. When light travels from a denser medium to a rarer medium to a denser medium, it bends towards the normal. Similarly, now suppose this is an interface that separates two media, denser medium to rarer medium. Now suppose it is going from a denser medium to a rarer medium. What will happen? It will bend away from the normal. So this is the angle of incidence, this is the angle of refraction. So now when it is going from a rarer medium to a denser medium, it bends towards the normal. When it is going from denser medium to a rarer medium, it bends away from the normal. So here angle of incidence is greater than angle of refraction. Here angle of incidence is less than angle of refraction. That means it is going away from the normal. And one more important thing you should remember, that when light incident obliquely on an interface, whether rarer to denser or denser to rarer, it will pass undeviated. The reason you can get later on why it will pass undeviated. So when it is going from rarer to denser, speed of light in a denser medium is less. If I will say speed of light here V1, your speed of light is V2, then how they are compared? So V1 here I is greater than R, V1 is greater than V2, and here I is less than R, so V1 is less than V2. That means speed of light is increasing here when it is going from denser medium to rarer medium. So this is how the light changes the direction when it goes from one medium to another. One more important point, children, you should remember. When light travels from one medium to another, the speed changes, so direction changes and wavelength also changes. Because you know there is a relationship between speed, wavelength and frequency. If you are going for wave theory, then you will get as the speed changes, speed is equal to, there is a formula, speed is equal to wavelength into frequency. Wavelength into frequency. If I write speed, for speed if I write V, and wavelength is lambda, frequency is nu, so V is equal to lambda nu. That means when light travels from one medium to another, speed changes, wavelength changes, but frequency remains constant. It does not change. Very important point, frequency does not change when light travels from one medium to another. Now let us see what are the laws of refraction. Similar to laws of reflection, there are two laws of refraction. According to first law, the incident ray, the refracted ray and the normal to the interface at the point of incidence all lie on the same plane. Second one, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media and for a light of given color. That means if you take the ratio of the sine of angle of incidence, suppose I is the angle of incidence and R is the angle of refraction. Suppose a ray of light is going from medium 1 to medium 2. So this is the angle of incidence, this is the angle of refraction. Now I have shown in the diagram light is going from a rarer medium to a denser medium. So it bends towards the normal. So here if you change the angle of incidence, accordingly angle of refraction changes. And the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. And that is not a universal constant. That is a constant for a given pair of media and for a light of given color or wavelength. That means this value is a constant and is represented by symbol mu21. Mu21 represents refractive index of second medium with respect to the first medium. And it is different for different media and for a light of given color. Suppose you take blue light and some value you are getting, and if you change the red light, then you will get another value. So the ratio is a constant for a given pair of media. And you see, if you draw the diagram, the incident ray and the normal and the refracted ray all are lying on the same plane. That can be also verified by conducting experiments. Then this is about laws of refraction. In my next video, I will discuss about the refractive index, that proportionally constant, in details. Thank you for watching.